Let's talk about Java input/output. For a lot of people, just hearing those words makes them think of super confusing code and way too many classes. But what if I told you it's actually all just a simple matter of plumbing? Yeah, you heard me. So let's dive in and make Java I/O feel incredibly simple.
First things first, let's ask the most basic question. You've written this brilliant program, right? But how does it actually talk to the outside world? How does it read from a file on your computer or send a report over the internet?
You see, right now, your program is basically an island. It's got all its own logic, its own power, but it's completely isolated. You've got your data over here, maybe it's a text file, maybe an image, whatever, and your program over there. That big question mark in the middle, that's the gap we need to cross.
And this right here is the core of the whole thing. It's the data flow problem. Your program is an island, and if it can't get data in or out, it's pretty much useless. The solution, luckily, is a really beautiful and simple idea: the stream. In Java, a stream is exactly what it sounds like. Just picture a stream of water. It's just a continuous flow of data moving from a source to a destination.
So we build a bridge, or better yet, we lay down some pipe. Streams are the pipes that connect our program's island to the mainland of data. And just like that, information can finally start to flow.
And that brings us to the single most important analogy for understanding Java I/O. It's all just digital plumbing. Seriously, once you see it this way, everything else just clicks into place.
So let's check out our first piece of plumbing, an input stream. Its job is incredibly simple. It's a pipe that brings data into your program. The direction here is absolutely key. It's always one way, from the outside world in.
All right, so let's get practical. How do we actually use these pipes to bring data in? In programming terms, we call this reading from a source. So, how does Java get it done?
Well, we need the right tool for the job. Meet the FileReader. Think of this as one of Java's pre-built pipes, specifically designed to connect to a file and start pulling in character data, like text.
Let's really lock this analogy in. Okay, so imagine the file is a giant lake full of data. Your program is a house, and it's thirsty. It needs that data. The file reader, that's the pump you install to get the water from the lake into your house. But of course, plumbing works both ways, right? What if your house, your program, needs to get rid of some water? Well, for that, you need an output stream. This is a pipe designed to send data out of your program and back into the world. Okay, time to flip the script. We're now focused on the opposite direction, piping data out. This is what we call writing, taking information that's inside your program and saving it to a destination.
And just like we had a tool for reading, we've got one for writing, the FileWriter. This is the pipe you connect from your program to a file when you want to send your data flowing outwards.
So let's put them side by side. It's super clear, right? FileReader is for reading. The flow is into the program. You're filling the house. FileWriter is for writing. The flow is out of the program. You're draining the house. They are two perfect halves of the same system. Okay, so we've got our pipes. We can get data in, we can get data out. Sounds great. But there's a catch, and it's a big one. By default, these simple pipes move data one tiny little piece at a time. For a big file, that is incredibly slow. So the question becomes, how do we speed this whole thing up?
It's time to supercharge the flow. It's not enough just to have a working pipe. We need an efficient one. It's time for a plumbing upgrade.
Let's go back to our analogy for a second. The slow way is like trying to fill a swimming pool with an eyedropper. I'm not kidding. You connect your pipe to the lake, you fetch one single drop of water, deliver it to the house, and then you go all the way back to do it again. Millions of times. It's exhausting, and it would take forever. So what's the solution? We use a special kind of attachment, a buffered reader. Now, this isn't a whole new kind of pipe. It's more like an upgrade you wrap around your existing pipe, like your file reader, to make it way, way smarter by creating a temporary storage area or a buffer. And here's the smart way. Instead of that little eyedropper, we attach a massive water tank. That's our buffer, right next to the house. We make one big trip to the lake and fill that entire tank up. Now, whenever our program needs data, it just grabs a whole bunch from the tank right next to it, which is almost instant. By making fewer, much larger trips, the whole process becomes ridiculously faster. So pipes, lakes, water tanks, why have we spent all this time on this analogy? Because this is not just some abstract idea. Understanding this concept of digital plumbing is absolutely fundamental if you want to write effective Java applications that do real work.
All right, let's recap the most important takeaways. Number 1, streams are the pipes for data in Java. 2, input streams like FileReader bring data in. 3, output streams like FileWriter send data out. And 4, and this is the big one for performance, buffers like BufferedReader are the tanks you use to get some serious speed.
And at the end of the day, that's why this is so critical. Any app you write that has to handle files, or user input, or network connections, it all relies on this flow. Mastering I/O is really a non-negotiable skill for building solid software. So I'm going to leave you with this final thought. Your program's real power isn't just in its internal logic, but in its flow, its ability to talk to the world. So the question is, are you going to be the master plumber who designs an efficient, free-flowing system? Or are you going to be the one who creates the clocks?